Hello, hi everyone. Welcome to the Stone the Brand. So this is the Shiva sir. Today, so I hope two exams went well. So anyway, maths over. So English also over. Now it's time for preparation of science exam. Okay. So I already given plan in the previous class. Okay. So that is about completely today two chapters, tomorrow morning, before afternoon two chapters. So again two times revision. So tomorrow afternoon two chapters, day after tomorrow morning, before lunchtime. So two chapters will complete. Then so day after tomorrow onwards, so afternoon onwards, completely 24th full preparation, full practice. Okay, so full practice will be there. So that afternoon and 24th completely revision. Okay, so completely revision will be there, complete practice will be there, complete preparation will be there. So inform to everyone. So ask your friends to join to the class, listen to the classes. So and one more thing, when I'm explaining electricity chapter, if you want explanation of light chapter, so you're explaining electric current, so I want light chapter, so can you explain the light chapter? Yes, if you want that, already made. So those are one remaining chapters other than the explanation chapter, so I already made a playlist. Okay, so just you can go and watch the playlist. Target physics 25 by 25 in that. So light reflection, diffraction, human in colorful world, electricity, magnetic effects of electric current. These four chapters, okay, video I made. No, these four chapters I made like a video. So just you can go and check. So one or two shots will be there. So that's fine. Just remaining completely, it's the explanation videos only. So whatever I'm taking live classes. Okay. So those chapters are there. Those chapters are there. I uploaded in that playlist. Just check once. So you can take. Okay. Now completely will work out on preparation of electric current. Today the two chapters are electric current and humanoid. Electric current and humanoid. Tomorrow light and magnetic effects of electric current. Light and magnetic effects of electric current. So light electricity we need to practice more because concepts are there, and at the same time problems also we need to practice. Problems also we need to practice. So that's why what I did. So first the explanation of electric current, after that based on that problems, based on that one problems, after completion of electricity, human in colorful world. So after that so based on that one question discussions will be there. After that so tomorrow before lunchtime I will complete two chapters. Those are light reflection, diffraction, and magnetic effects of electric current. So I'll try to complete these chapters. I'll try to complete these chapters. Okay, so we'll practice these chapters. So after that day after tomorrow afternoon, again these two chapters revision will be there. Again though remaining two chapters will be revised day after tomorrow morning. Okay, this continuous cycle will go on, and complete practice this time. So I'm giving so I'm planning for a complete preparation. So practice time, so practice time, problems, concepts. Okay, so case based questions, MCQs, and so concepts related problems, everything, because so in science, so very important is physics. Okay, so physics, once if physics questions are easy, if you write physics, definitely maximum will get good marks. So that we I hope you already know about it. Okay, if you attempt physics well, then remaining chapters automatically you will write good. Okay, so you'll get good marks. So because physics little twisted questions like that. Okay, so analytical questions like case based questions like this type of questions they will ask. So that's why so complete so some importance must be given to this physics. Okay, so then plan accordingly. So you are planning, so which chapters you are going to attend, which chapters you need to practice, and so plan like that. So plan and prepare well. Okay, so let's start electric current. Electric current is nothing but rate of flow of charge. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay. So 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. Okay. A simple definition is the rate of flow of charge. Simple definition is the rate of flow of charge. Rate of flow of charge. Or one more definition also we can go with that. That is the flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second is called electric current. Electric current. Okay, SI unit of current is ampere. Ampere you have to write small letter only. So while writing complete word ampere, so you have to write small letter. Starting you have to write small letter. Symbol you have to write capital A. We can represent symbol as a capital A, so capital A as a symbol, but the word completely how to write small letters only. So ampere you have to write. Understood? So that is very very important. SI unit. So MCQ's point of view very important. And one more question. So define SI unit of electric current. They will ask about define SI unit of electric current. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Understood or not? So that's enough. That is next one on 1 electron. So here one more thing, one more point is there. That is okay. That is so charges are moving on the conductor. So moving in the conductor, right? This is the conductor. So this is the conductor. Charges are moving in the conductor. Charges are moving in the conductor. So can we say only 1 electron flows, current is flowing? Only 2 electrons flows, will you say current is flowing? Only 2 electrons flows, will you say current is flowing? We can't say only 1 electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. So number of charges are moving in the conductor. Number of charges are moving in the conductor. So then only we can say current is flowing. Q equal to plus or minus Ne. So positive charge, negative charge, positive charge, negative charge, positive charge, negative charge, positive charge, negative charge. So Q equal to plus or minus Ne. Q equal to plus or minus Ne. Quantization of charge is nothing but okay. So quantization of charge is nothing but Q equal to plus or minus Ne. Q equal to plus or minus Ne. On 1 electron, okay, on 1 electron. Very good. So on 1 electron, 1.6 into 10 power minus 19 coulomb. Okay, on 1 electron, how much? So on 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. Okay. Okay, very good. So like this. And so in 1 coulomb, how many electrons are present? 1 by 1.6 into 10 power minus 19. 1 by 1.6 into 10 power minus 19. If you take up, then 1 by 1.6 into 10 power 19, then you'll get 0.625 into 10 power 19. Then if you take, so then you'll get 1 coulomb equal to, so 6.25 into 10 power 18 electrons. Okay, so this is the answer. Very very important. MCQ's point of view very very important. I am saying again and again, MCQ's point of view on 1 electron how much charge is present. So 1.6 into 10 power minus 19 coulomb. In 1 coulomb how many electrons are present? In 1 coulomb how many electrons are present? So that is 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. So these two questions are very, very important. Okay. And SI unit of current. SI unit of current is very important. SI unit of charge is very important. These all points you need to learn. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. Okay, so on 1 electron, this value is very important and this value also very important. So make sure that you are learning these 2 points. And next one. So we'll discuss about electrical elements. Electrical elements, will discuss electrical elements. Electrical elements. First one is cell. This is a cell, positive terminal, negative terminal, cell. Second one is battery. This is a battery, positive terminal, negative terminal, current is flowing. Battery. Okay, third one is open switch. This is the open switch. And fourth one is closed switch. Understood or not? Open switch and closed switch. Next one, fifth one is resistor. This is a closed switch. Open switch, closed switch, resistor. This is a resistor. And the sixth one is rheostat. And coming to the seventh one is ammeter. So eighth one is voltmeter. Eighth one positive terminal, negative terminal. Ninth one is wire joining. 10th one is wire crossing. 11th one is wire joining, wire crossing and bulb. Okay, so these are the electrical elements. Understood or not? Once again check here. Cell, battery, open switch, closed switch, resistor. Resistor is a device which is used to oppose electric current. Resistance is a phenomena. Resistor is a device. Resistance is a phenomena of opposing the electric current. SI unit of resistance is ohm. Okay, so here you can see, here 3 points are there related to resistance. Resistor, first point is resistor, and the second one is resistance. Okay, so resistance. And coming to the third one is ohm, and the fourth one is this, the symbol. Okay, resistor is a device which is used to oppose electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Okay, so once observe the points. So these are the points. So very important. Make sure that so you are practicing all the points. Okay, so first one is cell. Next one is battery. So third one is open switch. So the dot is compulsory, then only it is closed switch. So without dot, if you are, so very simple. Okay, very simple and easy to do mistake. Okay, so dot is there, that is closed switch. If dot is not there, that is open switch. So they will ask about okay, so they will ask in the exam So define open circuit and closed circuit. Define open circuit and closed circuit, they will ask. So this dot you have to mention. If dot is there, then that is closed circuit. If dot is not there, that is open switch, open circuit. Coming to resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Understood or not? And so here, and SI unit of resistance is ohm, and symbol for resistance. Symbol for resistance, very very important. And coming to rheostat, rheostat symbol is this one, and not only this one, we can also take, so rheostat symbol, this is the rheostat symbol. So like this also we can take rheostat, one more symbol. Okay, either this one we can write, either this one. Okay, so any one we can write. Understood? So, oh, sorry, not only this one, down we have to take down. Like this. Okay, either this one or this one we can. So one are at the top, one is at top, another one is the bottom. We can also take like this. Understood? So these two we can take. Any one we can take. Rheostat, rheostat. Sir, what is the use of rheostat? Rheostat is nothing but, so without changing the voltage source, without changing the device, so we can regulate the current. We can without changing the voltage source, we can regulate the current. We can regulate the current. So that is the use of rheostat. They will ask the definition. So what is the rheostat use? So without changing the voltage source, it regulates the electric current in the circuit. So same definition is there in the textbook. Same definition is there in the textbook. What are the points I am taking? Those are textbook related content only, textbook related terms only. Keep in mind. So coming to the ammeter. Ammeter is a device. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. So ammeter must be connected in series. Sir, why you are connecting ammeter in series? Why can't we connect in parallel? So in parallel, so different voltage, different appliances, different appliances require different voltage. Okay, so like a different operators, different appliances we are connecting parallel combination, right? So it's required different currents, but ammeter has fixed, okay, some fixed reading. Okay, so if it is more than current, if it goes, okay, then it is required limit. Then what happens? Slightly gets seated, slightly gets seated. That's why ammeter cannot connect in parallel combination. So okay, done. What about a voltmeter? Voltmeter cannot connect in series combination. Normally, what is the purpose of voltmeter? The purpose of voltmeter is to measure the potential difference. What is the purpose of voltmeter? To measure the potential difference. So potential difference, so across the two we can say resistor, or we can say appliances. Okay, so at the ends of the conductor, like that we have to connect. So if you connect one to one, so yeah, same current is flowing, no difference. Okay, there is no difference, there is no electrical pressure difference. Electrical pressure difference, so it measures the difference, electrical pressure difference. Understood or not? So that's why across two terminals, if it is connected, so then across the two ends of the metallic conductor, if you connect, then it measures the potential difference. Okay, so one it is at high potential, one it is low potential. So one point where it is high potential, another point is at a low potential. Then if you connect voltmeter, it measures. Understood or not? Voltmeter measures the potential difference. So if it is connected in series combination, so same current goes, no reading will be shown. So whereas ammeter have to connect in series combination only. Okay, it measures when current is flowing. Okay, so understood? That's the answer. And now you can see wire joining, wire crossing, electrical bulb. So I hope it is very clear. Now we'll discuss about electrical circuit. Electrical circuit. electrical circuit. एक electric circuit. A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. Okay, current should be in a closed loop path. So you can say, so I'm taking the bulb, this is the bulb. Okay, so bulb. So current is flowing. First one is conventional current and next one is electric current. So what is conventional current and what is electric current? We'll discuss. Conventional current. So here you can see conventional current and the second one is electric current. Conventional current and electric current. Coming to conventional current. Conventional current is nothing but flow of positive charges. So positive charges are moving from, positive charges. So you can see positive charges are moving from positive terminal to negative terminal. That is nothing but high potential to low potential. Whereas electrons are moving from low potential to high potential. Okay, conventional current. Conventional current is nothing but flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Sir, what is this conventional current and electric current? So before finding electron, proton, scientists were already using this statement. Okay, that is flow of positive charges is known as electric current. So let it be. So instead of changing that statement, so we will use as a conventional current. And after knowing that the movement of electron, passing of electrons gives electric current, so that will be considered as electric current. Okay, so conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. And here one more question is there, that is positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Negative terminal to positive terminal. That too, positive charges are moving from high potential to low potential. Here you can observe positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential, low to high. Okay, so low potential to high potential. I hope it is very clear, understood. So this is very important. They will ask one question. That is, so will electrons flows from high potential to low potential or low potential to high potential? So they will ask this question. Will electrons flows from low potential to high potential or high potential to low potential? So write down or explain. So always electrons will move from low potential to high potential. Low potential to high potential, that to negative terminal to positive terminal. Negative terminal to positive terminal. So keep in one this mind. Okay, so this about conventional current and electric current. Understood or not? Next one. So based on this one, only this question they will ask. And coming to the next one, Ohm's law. So we'll discuss about Ohm's law. Let's start Ohm's law. Na ni na ni na, na ni na ni na, na na ni na ni na ni na ni na, na ni na na ni na. Okay, so next. Ohm's law, Ohm's law. You can take Ohm's law. So coming to Ohm's law, first point is the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to I. Okay, so the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature, and physical conditions also same. So at constant temperature is very important. At a constant temperature, the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it. V is directly proportional to V equal to IR. V equal to IR. So coming to the materials required. So what are the materials required? So we will see here. So materials required. So materials required. Materials required. Point number one. Okay, that is first one is four cells of 1.5 volts each of each. Second one is nichrome wire is 0.5 meter length. 0.5 meter. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay, nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And next one, so ammeter. And next one, fourth one, voltmeter. And coming to the fifth one, switch. Okay, and the next one is sixth one is connecting wires. Okay, so I hope it is very clear, understood. Four cells of, so 1.5 volts of each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch and connecting wires. Okay, so next one, so we can take procedure. So before that, so according to the textbook we are considering, so procedure. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay, it is an alloy. Okay, so it acts as a resistor. So I am taking four cells, 1, 2, 3, 4. So here four cells you are taking, 4 cells. Okay, so then I am connecting ammeter. It is ammeter. Next one is resistor. Here is a resistor. Next one, switch we can take. This is the switch. So I am connecting first one cell, and the next one 2 cells, and 3 cells, and 4 cells. Okay, so you can take positive terminal, negative terminal. Current is flowing like this. Understood? So positive terminal, negative terminal. Here we are connecting the voltmeter. Here is the voltmeter. Okay, so switch, this is a key. So switch, so 1.5 volts. Okay, so I hope it is very clear. So first one is, so procedure. So actually this circuit diagram, so under that I'll write procedure. Under circuit diagram I'll write procedure. Check once. This is circuit diagram. Okay, this is circuit diagram. And coming to the next one, procedure to do that. Procedure. Okay, so what is the procedure to do this one? First one you have to connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect to two cells. Second one is connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, so you have to repeat the process for 3 and 4. Understood? And you have to mention in the tabular form given below. So you have to connect one cell, you have to note, right? First connect one cell and note down the reading of ammeter and voltmeter, and then connect to two cells and note down the reading of ammeter and voltmeter. So repeat the same process for 3 cells and 4 cells. Observe the reading and mention in the tabular form given below. Okay. So serial number of cells, and next one, ammeter reading is current, voltmeter reading is potential difference. V by I form is R. So from this one we'll get R equal to V by I. So that is a proportionality constant. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So here you can see it is a proportionality constant. Okay, so here you can see. So 1, 2, how many cells we are using? 4 cells. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Understood or not? If you draw the graph for ohmic conductors, if you draw the graph V on y-axis, I on x-axis, the graph is straight line. The graph is straight line for ohmic conductors. The graph is straight line for ohmic conductors. The graph is curved for non-ohmic conductors. So what do you mean by ohmic conductors? What do you mean by non-ohmic conductors? Ohmic conductors are nothing but the conductors which obey Ohm's law. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Understood or not? The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. For Ohm's law, for ohmic conductor, the graph is linear. Okay, starting from origin. So this is for ohmic conductors and this is for non-ohmic conductors. Okay, ohmic conductors and non-ohmic conductors graph. So very, very important. So make sure that you are practicing these points. Understood or not? So next one, so I'll discuss about resistance and resistivity. Resistance and resistivity. Resistance. So let's start resistance and resistivity. Resistance and resistivity. So factor depends on resistance is very, very important. Factor depends on resistance. It's very, very important point. Okay, so just check once. Here is I am writing resistance and resistivity. This side is resistivity. Okay, so first one is resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to directly proportional to L. R is inversely proportional to area of the cross section. So R equal to rho into L by A. So resistance, SI unit of resistance is ohm. SI unit of resistance is ohm and symbol. And one more point is here, resistance depends on temperature. Okay. Resistance, as temperature increases, resistance also increases. As temperature increases, resistance also increases. And also resistance depends on material of the conductor. Resistance depends on nature of the material also. Nature of the material we can write. Nature of the material. Okay. Resistance depends on nature of the material. Nature of the material. Understood or not? Nature of the material. I hope it is very clear. Understood or not? So next one, resistivity. So here you can observe resistivity R rho equal to R by A, R A by L, rho equal to R A by L. Okay, so SI unit of resistivity is ohm meter. Very, very, very important for 2 marks. Very, very important for 2 marks. SI unit of resistivity. Understood or not? SI unit of resistivity. So here you can see I am writing SI unit of resistivity. So rho equal to ohm meter square by meter. Meter get cancel. That is ohm meter. SI unit of resistivity is ohm meter. SI unit. Very, very important. Very, very important. Make sure that you are learning this point. In exam they will ask SI unit of resistivity. Ohm meter. Understood or not? So and one more thing here. Resistance also depends on temperature and resistance also depends on nature of the material. Nature of the material. Understood or not? Nature of the material. Nature of the material. Is it clear? So very, very important. Just check once. Just check once. So resistance and resistivity. Differences between resistance and resistivity. Very, very important points. So once again, note down these points. So learn these points. Okay. So these are very, very important points. So check once here. So if you like the content, if you like the channel, do like, share and subscribe to Student the Brand. So these are very, very important. So resistance and resistivity differences. Resistance and resistivity differences. So resistance is directly proportional to length of the conductor. And here one point is there, resistance depends on physical dimensions, that is nothing but length and area of the cross section. So they will ask this point, resistance depends on physical dimension, that is nothing but length and area of the cross section, but resistivity does not depend on physical dimensions. So resistivity does not depend on length and area, but resistivity depends on temperature and nature of the material. Temperature and nature of the material. Understood or not? I hope it is very clear. Okay. Okay, so now we will discuss about resistors are connected in series combination, resistors are connected in parallel combination. We will discuss that point. Resistors are connected in series combination and resistors are connected in parallel combination. Okay, so let's check those point. Let's check that point. Resistors are connected in series combination and resistors are connected in parallel combination. Let's start. Let's start the war. Dun, 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 dun. Dun, 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 dun. Resistors are connected in series combination. Resistors are connected in series combination. Series combination. Series combination. Okay. So I'm taking 3 resistors. So very good, Kunal Sharma. Nice job. So I'm taking here 1, 2, 3. So this is the ammeter. Next one. So here is the battery switch. Positive terminal, negative terminal, current is flowing. This is R1, R2 and R3. R1, R2, R3. Understood or not? So now you can see across R1, across R1 I am connecting V1. So potential difference V1. Across R2 I am connecting V2. Across R3 I am connecting V3. Okay, so positive terminal, negative terminal, positive terminal, negative terminal, current is flowing. So positive, negative, current is flowing. Understood or not? So now you can see here, from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Understood or not? Okay. So very good, ma. Thank you. And now you can see throughout the circuit, current is same. Is equal to I1 equal to I2 equal to I3 equal to I. So throughout the circuit, current is same. Throughout the circuit, current is same. So that's why I'm taking here. So but potential difference is different. Throughout the circuit, current is same. Potential difference is different. So Vs equal to V1 plus V2 plus V3. So Vs equal to V1 plus V2 plus V3. So that's why I'm taking IRs equal to IR1 plus IR2 plus IR3. Okay, so I'm taking I common. I am taking common. So R1 plus R2 plus R3. R1 plus R2 plus R3. So here I can take I common. So so I is common on both sides. So I am cancelling I. So the remaining value is, so Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, R is equal to NR. If n number of resistors are connected in parallel combination, R is equal to NR. Understood or not? So this point is very important related to this one. So they will ask question and related to this one also. And here one more question they will ask, that is, which physical quantity is constant in series combination? So what is the physical quantity? So if you know the answer, let me know. So which physical quantity is constant? Which physical quantity is constant in series combination? So let me know the answer. The question is, so I am writing here. Which physical quantity is constant in series combination? So question is, answer to the question, which physical quantity is which physical quantity is constant in series combination. So can you tell anyone what is the answer? Which physical quantity is constant in series combination? So if anyone knows the answer, let me know. Very, very important. So let me know the answer. Which physical quantity is constant in series combination? Which physical quantity is constant in series combination? Okay. So answer is current. Answer is current. Current is the physical quantity which is constant in series combination. Current. Answer is current. So here you can observe. Here if you observe this one. Current. Current is the answer. So here throughout the circuit current is same. That's why this is the physical quantity. So which physical quantity is constant in series combination? So the answer is current. If coming to parallel combination, which physical quantity is constant in parallel combination is potential difference. Okay, now we will discuss about parallel combination. So parallel combination, parallel combination, parallel combination, parallel combination. Pum 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 pum. So from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So I equal to V by R. From Ohm's law, V equal to IR. I equal to V by R. So here potential difference is same across R1, R2, R3. So Vp equal to V1 equal to V2 equal to V3 equal to V. Okay, potential difference is same. So that we can write from Ohm's law, Ip equal to I1 plus I2 plus I3. Ip equal to I1 plus I2 plus I3. That is V by Rp equal to V by R1 plus, so V by R1. So V by R1 plus V by R2 plus V by R3. So I am taking V by V common, 1 by Rp, that is V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So VV get cancelled. So shall I cancel VV? The remaining values are, so 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Understood or not? If n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. So Rp equal to R by N. So check once. Check the concept. Very, very important concept. So series and parallel. Series and parallel. If resistors are connected in parallel combination, if resistors are connected in parallel combination, okay, so we can check. So potential difference is same. Potential difference is same in parallel combination, but current is dividing into according to the resistors through R1, I1, or through R2, I2, through R3, I3, and potential difference same. So Vp equal to V1 equal to V2 equal to V3 equal to V. Then, so current is different, so that's why I'm adding all the currents. Then by that from Ohm's law, V equal to IR, I equal to V by R. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So then you will get the answers. So if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Rp equal to R by N. I hope it is very clear. So this is about electric current. Resistors are connected in parallel combination. Resistors are connected in parallel combination. So now we will discuss about heating effect of electric current. Heating effect of electric current. Understood or not? So let's start heating effect of electric current. Mhm. So resistors are connected in so series combination, parallel combination we discussed now. Okay, so now we will discuss about heating effect of electric current and also known as Joule's law of heating. The source of energy continuously gets dissipated. The source of energy continuously gets dissipated entirely in the form of heat. It is known as heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current, or also known as Joule's law of heating. So V equal to W by Q. So that is W equal to VQ. So we know Q by T is current. Q by T is current. Rate of flow of charge. Rate of flow of charge is called electric current. So now, so P equal to W by T, that is VQ by T, that is nothing but V into Q by T, that is P equal to VA. Okay, so P equal to VA. So we know energy is given to the conductor P into T. So what are the energy that will become in the form of heat? So V into IT. So V equal to IR. V equal to IR. V equal to IR. So H equal to IR into I into T. So that is H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. I hope it is very clear. Once again, heat produced in the conductor. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. heat produced in the conductor is directly proportional to time. So I hope it is very clear. So this is about heating effect of electric current and also known as Joule's law of heating. Joule's law of heating. I hope it is very clear. So next we will discuss few problems. Okay. So we'll discuss problems. Those are very important. Let's solve. So try this question, try to solve this question. So what is the answer? Let me know. So here you can observe here a copper wire of resistivity. Okay, so a copper wire of resistivity is given. So a copper wire of resistivity. Understood? So how much? Here you can see a copper wire of resistivity is given. This is the resistivity. Resistivity has a cross-sectional area. This is a cross-sectional area. Calculate the length of this wire. So we have to find out the length of this wire. Okay, to require to make a 10 ohm. Okay, so we have to make it 10 ohm coil. Right, so that is resistance given. Already this is the resistance. Resistance is given. Understood or not? Now you can write the given data. So you can write the given data. First one is, so rho equal to given data. Given data. First one is rho equal to 1.6 into 10 power minus 8 ohm meter. Second one is, so area of the cross section is 20 into 10 power minus 4 centimeter square. Okay, so and calculate the length. So we have to find out the length. Okay, so we have to find out the length. And here they given R equal to how much? R equal to 10 ohm. R equal to 10 ohm. So now you can observe here they given in centimeter square. Okay, so we have to convert into meters. We have to convert into meters. They given in centimeters. We have to convert into meters, right? Yes. So 1 meter equal to, so 1 meter equal to 100 centimeter. 1 meter equal to 100 centimeters, right? 1 meter equal to, you can take the 1 meter equal to 100 centimeters and 1 centimeter equal to, so 10 power minus 2 meter. 10 power minus 2 meter. So they asked centimeter square. So 1 centimeter square equal to 10 power minus 2 whole square meter square. That is 10 power minus 4 meter square. So 1 centimeter square equal to 10 power minus 4 meter square. Okay, so now you can see here. So substitute the values. So what we have to find out? L. R equal to rho into L by A. So from this, L equal to RA by rho. RA by rho. So that is a question, very very important question. Very very important question. Okay, so for exam, very very important question, keep in mind. So that is L equal to rho, R equal to how much? 10, and area of the cross section is 20 into 10 power minus 4 meter square. So anyway, meter square, then rho equal to how much? 1.6 into, so 10 power minus 4, again 10 power minus 4 is there here. 10 power minus 4, instead of 1 centimeter square, again we are multiplying with 10 power minus 4. Okay, so after that you will get 1.6 into 10 power minus 8. Then L equal to 10 into 20 into 10 power minus 8 by 1.6 into 10 power minus 8. This get cancelled. So L equal to 200 by 1.6. So if you multiply and divide, then you will get 2000 by 16. That is nothing but 125 meters. So L is 125 meters. Let me know the answer. Is it correct or not? Let me know, is it correct or not? Check once. Check once the answer. So let me know the answer. Is it clear or not? Is it correct? So next we'll do one more. That is next question. We'll solve one more question. So try one, check the question. One, check the question. Is it correct or not? So 125 meter is the correct answer. 125 meter is the correct answer. One more problem, I'll do it. One more problem. Okay. One more problem. So next problem is next problem. So aluminum wire has radius. So next question, aluminum has radius. Aluminium, aluminium wire has radius. Wire has radius. Okay, wire has radius 0.25 mm and length and length 75 meter. If the resistance of the wire is 10 ohm, calculate the resistivity of aluminium. Okay, so identify the answer to this question. Check once here. Check. So let me know the answer. So they're asking to find out resistivity. So R given and so resistance is given, radius is given 0.25 mm, length is given 75 meter. Okay, so identify, find out the answer. What is the resistivity? So check here. First you have to identify the given data. Here radius is given. Radius is 0.25 mm. Radius is 0.25 mm. Understood or not? Radius is 0.25 mm. Understood? And the length is 75 meter. And resistance is 10 ohm. So we have to find out the resistivity. Okay. So we have to calculate the resistivity of the aluminum. Understood or not? So and one more thing, check once all the given. Okay. So all the given physical quantities are there in one system or not. Are the given data there in one system or not? We have to check. Okay. So we have to check. So check here. 75 meter, that is length. Given data. So come to the point. Given data. So L equal to 75 meter, and here resistance is equal to 10 ohm, and coming to the radius, so R equal to 0.25 mm. 0.25 mm is given. Understood or not? So we have to convert into meters. So what is the required data? So resistivity. So here the formula is R equal to rho into L by A. So rho equal to resistivity they are asking. Rho equal to RA by L. So L we know. and R we know, so L we know, R we know, but area equal to pi r square. Pi r square. Pi equal to 3.14. 3.14 or 22 by 7. Okay. So 22 by 7. So you can take anything. 3.14 or 22 by 7 we can consider. Understood? So anything you can take. Anything you can take and substitute the values and do the solution. Understood or not? So here you can observe R equal to rho into L by L. So rho equal to RA by L. Rho equal to RA by L. So substitute the values. So R equal to how much? 10. And so 3.14. Here you can observe 1 meter equal to 100 centimeter. 1 centimeter equal to 10 mm. Then 1 meter equal to 1000 mm, that is nothing but 10 power 3 mm. So that is 1 meter. So 1 mm equal to 10 power minus 3 10 power minus 3 meter. Understood or not? 10 power minus 3 meter. Okay, so substitute the values. Substitute the values. Here we'll get here again 0.25 is given into 10 power minus 3. So we can also write 25 into 10 power minus 5 meter. Understood? So 10 into 25 into 10 power. So this calculation is very important. Calculation is very important. Make sure that so you are attempting this one. Understood? So now you can take 3.14 into so pi r square. Pi r square. So this is r value. This is r value only. R equal to this is r value, right? From this one. So you can take like this. Okay. Then you can substitute 3.14 pi r square. Pi r square 3 point. So 25 into 10 power minus 5 whole square by L equal to how much? L equal to 75. So how much is the answer? So let me know the answer. Okay. So let me know the answer. What is the answer? 25 into 10 power minus 5 whole square by 75. How much is the answer? Check once. The answer is 2.61 into 10 power minus 8 ohm meter. So check once. Here from this you'll get answer 2.61 into 10 power minus 8 ohm meter. Is it correct or not? Is it correct or not? Let me know. Is it correct or wrong? Let me know the answer. Let me know the answer. So check once the question and answer. So we'll go to the next one. So next question is coming to the next question. Coming to the next question, a current of, question number 1, a current of 500 milliampere flows in flows in flows in a series circuit containing an electric lamp an electric lamp and a conductor of 10 ohm when connected to 6 volts battery 6 volts battery. Okay, find the resistance of the electrical lamp. Understood? So this is the question. Try to identify the answer. Okay, so very simple, very easy. So very important question. Okay, so check once. So you have to find out. Very important question. Very important. So I'll go for a 5-star for this question. Okay, so expected for exam. This type of question. So let me know the answer. A current of 500 milliampere flows in a series circuit containing an electrical lamp and a conductor. So 10 ampere is given. Okay. 10 ohm and connected to battery 6 volts battery. 6 volts is given. Okay. So check once. Let me know the correct answer.
So hi everyone, my name is Prashant, and today we're talking about last minute.
Okay, so the answer is So answer you will get you have to get 2 ohm. That is the correct answer. So here you can see can observe. So a current is given how much? I equal to 500 milliampere and flows in a series circuit containing electrical amp of conductor. This is a conductor. Okay, so RC given conductor, that is resistance of the conductor is 10 ohm, and when connected to battery, okay, 6 volts, V equal to 6 volts, and find the resistance of the electrical lamp we have to find out. Okay, so that is RL. RL we have to find out. From Ohm's law, V equal to IR. V equal to IR. So 500 milliampere. 1 milliampere equal to 1 milliampere equal to 10 power minus 3 ampere. 10 power minus 3 ampere. Understood or not? 1 milliampere equal to 10 power minus 3 ampere. Now, so V equal to 6 equal to 500 into 10 power minus 3 into RC, RL plus RC. RL plus RC. Understood or not? So here we know RC. RC how much? 10 ohm. Okay, RC equal to 10 ohm. So it goes down, then you'll get 6 by 500 into 10 power minus 3 equal to RC plus RL plus RC. Then if it is goes near the numerator, then you'll get 6,000 by 500, so equal to RC how much? RL we have to find out. RC equal to 10. RC equal to 10. Understood or not? So here these two get cancelled. 5 12 ja, then you'll get 12 equal to RL plus 10. RL equal to 12 minus 10. Then you'll get RL equal to 2 ampere. This is the correct answer. Very important. Very important. So make a mark. Okay, so very important. For exam point of view, check once. Is it correct or not? Is it correct or not? Check once. So related to Ohm's law, one more problem we'll do it because this problem is very important related to Ohm's law. Video as I said, so practice session will be there. Okay, related to Ohm's law, we'll do the problems. Okay, so I'll just check once. Related to Ohm's law. So like table, so in an experiment of verification, verification of Ohm's law, so following observations are made. following observations are obtained. Following observations are obtained. Okay, so I'll mention in the table column. So check once here. This is the tabular column. So V and I. So here 1, 2, 3, 4. So 0.5, 0.2, 1.0, 0.4, 1.5, 0.6, 2.0, 0.8, 2.5, 1.0. Okay. So first question is, so the potential difference. Anyway, we have to draw the graph. Draw the graph by using these values. So I have to draw the graph. Observe the graph. The potential difference V when the current I is 0.5 ampere. So current is given. Okay, we have to find out the potential difference. Second question is the current I when the potential difference is 0.75 volts. And coming to the third one, the resistance in the circuit. The resistance in circuit. Okay, so find out the answer. Let me know the answer. What is the answer? Check once here. So the table is given. Okay. So we have to find out potential difference. We have to find out the potential difference. Okay. So potential difference V when current I. So current is given. We have to find out current I when the potential difference is set. So we have to find out current and the resistance in the circuit. So to find out all these things, we have to find out the resistance. First to find out the resistance. Okay. So the formula is V equal to IR, right? So V equal to IR and R equal to V by R. So that is V2 minus V1 by I2 minus I1. Okay, so now V2. So I'm taking this one, this. Okay, na? So interval, you can take 2, 5. Now, so 2 minus 1.5 by, so 0.8 minus 0.6. This is V value, this is V2 and V1. This is I2 and I1. Okay, then if you are doing, so R value, you'll get 0.5 by, okay, 0.2 into 10 by 10. Then you'll get R equal to 5 by 2, that is 2.5 ohm. R you got 2.5 ohm. Okay, so that is R value. Then you can take, so now potential difference we have to find out. First one is find out potential difference. We have to find out. Okay, so we have to find out V. We have to find out V value. V value, then R equal to 2.5 ohm, and so current is given. Current is how much? 0.5 ampere. So V equal to IR. So 0.5 into 2.5. So what is the answer? Can you let me know the answer? So that is the first one. Coming to the second one. So current we have to find out, and potential difference is given 0.75 volts. So R value 2.5 m, 2.5 ohm. So now V equal to IR. V equal to IR. So 0.75 equal to I into 2.5. I equal to 0.75 by 2.5. So I value how much? And the third one is, you found the R value. R value how much? So 2.5. 2.5 ohm. So check once this answer. Check once. Is it correct or not? So the answer is 1.25. Here 1.25 volts. Okay, volts here. And here you'll get 0.3 ampere. Is it correct? Is it correct? 0.3 ampere and 1.25 volts are equal to 2.5. Is it correct or not? Check once. Okay, so again we'll come back and do the problems. So thank you so much for joining. Do like, share and subscribe to Student the Brand. If you like the content, if you like the channel. So thank you so much. We'll see you in the next class. Okay.